Alright, so let's continue with this visualization stuff. What do we got? We've got this. Okay. So first of all, this temporary memory nonsense. I think D has some feature that can help with that. I think those features would be the mix and template. Yeah, mix and template. Yeah, so you can declare things using it, and you just mix in foo. And you end up with return y. Yeah, it just puts that. Actually, what does it do? Int y is 3. That's a function that returns y. So you mix it in here. Oh, so you declare a function inside of this, and you call it, and it returns 8, which is that. Yeah, okay. And I think it has to be a mix and template, like a normal template. Like a normal template. Can a normal template do it? Template instantiation. Well, these are really... Alright, let's see what are they? Member variable of time t within template t. Okay, so what does this do exactly? T instantiated. Must template instantiation, template so you access them this way. Okay, so like, oh god, the single letter temple. It's like temple int. I mean, I don't even really know. So what does this do? Has no effect. X equals 1. Like, I don't know. Is used as a type. Okay, so it's not a type. Not a null value either. So what am I supposed to do with it? Alias pointer. Declare X to be of type int star. Pointer equals T star. Okay. Common instantiation A. So you can. So it's for creating types. Looks like. Practical example. Okay, well that defines a function. Scope. Yeah, so really these are for defining functions, I guess. I mean, I can also define a struct or something that way. But you can't really, like, template mix and stuff can be used for defining variables. Like if you do this, and then you do foo. Oh god, what is it? Mix and foo? Yeah, mix and foo. So now we have a Yeah, now we have a variable in here called x. Yeah, we do. So that just inserted itself in here. Okay, alright. Can we use like current line, current function name, that sort of thing? Is it in dlang, like what's the equivalent of like line? Alright. It looks like it's just a file. Oh yeah. Okay, well, can we do something like mix in x line equals 5, like is that not allowed? It is not allowed. Like, well, I mean, how about that? Is that allowed? No. Equals 5. I don't even, like, is that allowed? Okay, so that's kind of do what I want. Need to end the declaration. Yeah. Oh, there you go. So what I can do is something like this, right? Temp. Alright, equals. I mean, we do kind of want to take a variable though, so can we take a variable in here? Like, does this have to be a type, or what's like int 1, int x? Like, is that allowed? Maybe 2. Is that allowed? Mix foo. Okay, now that is just like I don't know. Like, is that allowed? Oh, that is allowed. Okay, so like equals x. Like, is that allowed? Seemingly. Okay, do we have x in here, or like temp 15? There we go. Temp 15 equals 2. Okay, well that. Yeah, that's kind of what we want. Now instead of being an int, let's just make it an arena. Can this be an ref arena? Is that something that we can do? Basic type expected. Okay, well, how about that? Yes. Okay, so that is allowed. It can be a pointer. It cannot be read at compile time. Also, what? So this has to be a compile time known parameter or something like. I mean, really, I just want this. Like, temp line equals. Instead of doing it this way, right? Temp line equals temp memory scratch semicolon. Yeah, I think that's what we want. well, it's not. Yeah, so I want to do this in order for the name to be like unique, because in general it'd be nice to have unique names, so I can just put that in anywhere within the function and not have to keep all these names unique myself. Well, there it is. That is a unique name. Which is what I want, but like I don't want to write the mixin every time. Can this be put into anything that I can just invoke? Presumably it kind of can. I mean, this scratch thing. Temp memory block. Temp memory block. Well, like I just want to pass that essentially to it. I mean, I guess I can pass a string, and that'll work. Because this scratch thing, like that has to be. Name. Is that it? And not regular templates. What are you talking about? Oh yeah, mix them. This error message is just so bad. Just tell me to put a mixin in. Oh my god. What does this do? Well, there is our temp 15. Oh no. Oh no. This is this line, not this line. Oh, that's. Oh god. Oh no. Yeah, that's awful. That is awful. I mean, at this point, you might as well write a mixin yourself. But I don't want to do that, man. C macros are actually pretty good, I'm realizing. The C preprocessor, man, what a great metaprogramming facility. Like, so easy to use and so versatile, as opposed to whatever this is. Like, it can't do basic things, like create a unique variable name. Okay, well, this almost works, right? This almost works. So, like, what, do I just do that every time? Every time there is a... I mean, this is so inconvenient to write that you might as well just write the normal code and just keep these names unique manually, like an idiot. Like temp, and then if you have another one like temp1, like if we had to have another one in here, it would be like temp1. I mean, at least it warns you when there's a shadowing problem going on. Which, I mean, I think shadowing is allowed. Like, I think shadowing is allowed. No, it's not. It's actually an error. Yeah, shadowing is not allowed. Yeah, so you do have to keep them unique. Like, man, that is awful. Give me my preprocessor back. Okay, so that's not gonna work. Alright, well, I guess we'll just keep it this way. Whatever. Ah, it's so bad. Okay, I'm gonna have to go take a break. Just mute the microphone. Alright, let's continue. With actually trying to draw something, which I'm thinking for this first question, what we have, like the data that we have, is, and well, it's an array of numbers that represents, calorie counts, I guess, that the elves are carrying. So we can draw a histogram out of that. So to begin with, this is the data. So we can just take this array of sums. So this is the pointer and this is the count. And for each sum, we can draw a rectangle and then arrange them in a row, and that'll be a histogram. Of course, we have to convince Micro UI to actually do that for us. And the way that's gonna work is we're gonna have to create our own widget. Somehow. Alright, let's see. Does Micro UI come with instructions? Doc usage MD. Yeah. Well, I'm already doing this. Layout system. Based around rows, yeah. Mu layout row, yeah. When a row is filled, the next row is started. Zero, which will result in style size being used, or negative, which will size relative to the parent, right? So layout row, button, yeah. Column can be started at any point in the row using begin column. Rows will act inside the body of the column. All negative size values will be relative to the column's body. All new rows will be contained within the column. Internally, mu layout next. You should use this function when making custom controls. The mu layout set next to set the next one explicitly. I see. Style customization, custom controls. Well, there's an example. Get ID, value, size of value. The control should take a context as its first argument and return mu res value. Your controls implementation should use mu layout next to get destination rect and advance the layout system. It should be used with some data unique to the control to generate an ID for that control, and that should be used to update hover and focus values based on the mouse input state. Okay. The mu opt hold focus can be passed to retain focus when, yeah, a control acts as a button. Okay, yeah, this is an example. So get ID, layout next, update control. which, I mean, it's not really a control what we're doing. We just want like a just want to draw some rectangles, really. And yeah, I suppose that is a big difference between this. Okay, so we can do something like this, right? Mu draw text start, which comes from end. Start equals end equals p. Okay. Start length position r. What's r? Where did r come from? Mu layout next. Yeah, so it came from. I think you can also get bounds. Micro UI.h. Let's see. Data enums. Vec correct color init begin end. Set focus. Check. Get container. No, that's by name. Pool. Okay, well, we don't need that. Input, now push command, next command, draw text. Well, yeah, draw rect is gonna be the thing we use. Draw control frame, draw control text. Well, it's not a control. Mu mouse over. Okay, mu text, label, button, checkbox, text box, slider, number, begin tree node, entry node, begin window, begin pop, end panel. Okay, so can we just, so I do, what does it do again? Begin column, layout row, layout next. Okay, so the rect is something we can get from this mu layout next thing. Okay, well, let's just see what it is. No. Yeah, okay, there we go. R. We want R. 2, 14, 30, 23, 12, 13, 76. Yeah, that looks like the whole rectangle. I wonder, like, since we called new layout next, where's the text gonna be drawn? Down here. Yeah, that makes sense. Yeah, alright. Okay, so this is how we can get the rectangle. That just kind of fills bounds, I suppose. Okay, so this is the bounds within which we're supposed to draw our stuff. So mu rect. Is it draw rect? Draw. Okay, draw. Draw rect. Yeah. Mu draw rect. Context, rect, and color. Well, bounds, mu, color. Okay, mu color. RGBA. Oh yeah, look at this beautiful magenta. Yeah, now we just, well, we need multiple ones of those. One for each sum. Let's start there. For each sum, this is like what's the result? Sums. I mean, I guess we can just take a slice. Result elf count. Oh god. So we can draw a rect for each of these arcs. So the width of the rectangle is going to be fixed. Int rect. Well, I mean, I guess mu rect hist rect. Let's start here. Mu rect. Okay, how is this parameterized? X, Y, width, height. Well, X, I mean, yeah, let's just put it inside the bounds. X, Y, well, width is going to be fixed, and then height is going to be the thing that we vary. So hist rect height. Let's just set it to the sum. Why not? Let's just set it to the sum. And just see what that does. Is it mu draw? So if we want to draw a border, then that's a separate thing. Hist rect x plus equals hist rect height plus 5. So that's good. Yeah, let's just do that. Okay, well, that's not really what I expected at all, because I'm not using it. Okay, well, that's something. We only have one rect though for some reason. Okay, let's look at the first rect. Break. Yeah, it's very big, I see. Well, let's make its height smaller. And okay, so it's top down. Well, we're gonna fix that at some point. But where is all the other rects though? No, wait, it's height. Height plus no. Width. So width plus 5. Okay, well, that is a bunch of rects. Now, kind of wanted to scroll, you know, horizontally, which it's not doing exactly. So I need to let micro UI know that the contents that I'm filling, they're larger than wow. I mean, I suppose that's a layout issue. Like if we up front say something like if we up front say something like, you know, layout row but the width is gonna be like, instead of being this width, it's gonna be, well, I mean, this has to be 10,000 or something. 10,000. Yeah, it's just really big. Then it should let us scroll. Although I don't know what's gonna happen to the rectangles. Okay, the rectangles actually, yeah, that works. That works. Except that I want this part to scroll, but not that part. It's just the lower part needs to scroll, and we also need to bind something to the horizontal scroll. Let's do that. So there's probably a way to get, like, modify a key state from here. Okay, W param. Control, left mouse, middle mouse, right mouse, shift key. The high order word indicates the distance the wheel is rotated. Expressed. The low order word indicates which keys are down. Okay. hello world message wparam. What does it do? Use short mods. Bool shift down. Oh yeah, just bool shift is what? MK shift mods and MK shift. If shift else, so else that, but if shift then that, just switch them around a little bit, like that. Cannot cast int to bool. Shift means this is not 0. Okay, yeah, this seems to be working fine. Okay, so we bound the thing, we bound the input, so we can scroll left and right. Now somehow we need to make it so it's the lower part that scrolls and not the upper part. It's this part that scrolls. And we also need to make the width make sense, since it's 10,000, clearly too big. Okay, well, the lower part scrolls, the upper part does not scroll. Yeah, okay. So result string. I see. Okay, well. Okay, so this row is lying within the same panel. So presumably that's why the size of this row affects the behavior of this row. So does that mean we need to put it into its own panel? Probably. Well, okay, how are we gonna do that? Well, we just begin panel. We can begin another panel. Like that. Begin panel. So this is gonna be solution result string, and this is gonna be solution result wrap. Yeah. This is holding it. Okay, so now they're in different panels. Oh dear God. Well, that's interesting. Well, I mean, being in different panels definitely does help. Now, like a little bit. They are scrolling independently, they're just really small. And actually, what exactly is happening there? Well, the panels lie within this small part. So something lays it. Something puts them in there, right? It's like it's probably this or something. Like, yeah, we basically we need to do one of those. Well, actually, even, well, yeah. So let's do one of those. That's before doing anything, we just do that. And this is gonna be like -1 for the height, let's say. So give me one row That's just the whole thing. Yeah, well, let's actually, what does that do? Okay, well, that does something. I don't know where the rectangles went. But actually, the rectangles I think are there. Oh wait, do I need to do the layout before doing the panel? Like, does this need to go in here? Okay. What does this do? Okay, this kind of does what I want. Kind of. I don't know why it clips it like that. Kind of does what I want. So there is the panel. Not laying anything. Wait, do I need to also do it this in like in here? Yes. I mean, apparently, like it's like there's padding involved, so it's all like messed up a little bit. I think if we just make that first row wider, okay, now it fits. Okay, so this is a okay, oh god. Okay, so what's happening here is we begin a panel, then we lay out a row, then we begin the panel again, and this panel goes into this row. So the panel goes into the previously defined row layout. Okay, alright. But then within the panel, we also need to do this again, because if we don't, then it uses probably some default sizings or something, which is not what we want. Yeah, so that is what we want, for sure, for sure. Okay, so now there are some, I guess, flags we can pass to begin panel. Yeah, so we can pass some options. What are those options? Mu opt. No frame, no resize, no scroll, no close, expanded, autofocus. Well, I mean, okay, if we look at it again, so this panel, like it has this padding away from the parent, and it has a border as well, which, I mean, I don't know, if we pass no frame, will that make the border go away? No frame. Yeah, it does make the border go away. Well, yeah, we probably don't want the borders on these panels, so let's pass no frame to both of these. And now, yeah, this padding is probably fine, whatever, keep it there. Now what's going on with this, this second one? Well, again, we need to lay out a row, but this time the height here is going to be just like the parent, pretty much, -1 pixel. Okay, now the scroll bar is where I expect it to be, down here. Well, kind of. I mean, well, I guess it's fine to have a little bit of padding there, whatever. Okay. Okay, so of course using it, like you can't really pass an array literal. Or can you? No, I don't think you can. I mean, we could always just, like, we're gonna be using this a lot, so we can just write a wrapper for that function specifically. That's more convenient to use with D. Although, what's that function gonna be? I don't know. Let's think about that. But before we do, let's make sure those are different, like those rectangles are making sense. So let's set the default height to 10 and then just like increment it by 1. Yeah, so that does make, okay. So this is the correct way of scrolling them. Alright, so let's figure out these so big, yeah. Let's figure out these weird layout row thing. Like, can we make that less bad? Layout row, void layout row. I mean, it'll pick up on new context, right? So, well, it's basically, where's this layout row? Here. So it takes that, it takes, this array is what we need to figure out. This array, how do we pass an array? Well, I mean, it's a slice, right? So like int slice widths int height. That's what it is. Really? I have to cast? But like I don't have to cast here? I have to cast here, but not here. Okay, interesting. Well, does that work? Okay, so that works, but still kind of bad though, because I just want to pass like that, essentially, like a literal. Like, can I like just take? Well, just create a temporary array, like pass it in, like what the. Does this have to be, like, if this is an int2, like, is that gonna work? Okay, that does work. So do we have to make it, like, int count? Count. Like, do we have to do that? Well, I mean, I guess that works fine, right? Yeah, that does work. Layout row. Is this actually working? Is this still? Yeah, that is correct. Yeah, I mean that's not bad. I mean, it would be even better if I could just have a literal slice that just creates a temporary on the stack and doesn't require garbage collection. But I guess I'll take what I can get. layout row begin panel. And inside the panel layout row again. That seems to be working. Yeah. Well, okay, so this width right here. Well, we sort of know what it is, right? We have one like int rect width 0 int rect pad. Let's say is 5 10. Okay, width is 10, pad is 5. Total width is rect width plus rect pad times result elf count. I mean, the last rect doesn't necessarily have a pad, so I mean, I guess technically it's like result rect width times that plus rect pad times result elf count minus 1. Total width. Yeah. This lets us scroll all the way to the end. Yeah, now the heights. Well, the height is a sum, right? But we need to scale it. Scale sum from, well, let's say from 0 to whatever it comes from. Actually, we do have a max sum, right? Result max sums 0. So that's the top sum. So that's the original range, and we want to scale it to bounds. How is it parameterized again? Mu rect x, y with height. Yeah. Well, the minimum would be bounds y plus bounds height, and the maximum would be bounds y. And we can just define this scale function like somewhere. Let's say here. So it scales integers, right? Scale int value, int og min, int og max, int new min, int new max. Yeah. Okay, so the value goes from min to og max, so value minus og min. So now it goes from 0 to og max minus min. Int og range is og max minus og min. So if we divide that by the range, I mean, we're gonna have to cast to a float first. So now this goes from 0 to 1. Yep, and then we can just int new range is new max minus new min float float is val01 times cast float new range plus cast float new min int val int well, I guess this is new val int is cast int new val float. Okay, return new val int there. Yeah, something like that. Scale. Right, let's see. Well, let's see what happens there. Well, that's kind of like what I expected. Let's step through that. Actually, hold on. This is the height, right? So, no, the height, the new height actually goes from 0 to bounds height. Yeah, that's what the new height is. Let's see what that looks like. Yeah, it looks like that. So we can kind of see where the maximums are. I guess there are two in this case. That's what it looks like. Maybe they're slightly different. Yeah, so this is an upside down histogram right now, which works for us. I mean, we can flip the rect pretty easily. Like we know mu is gonna draw it sort of upside down, so we could just say, well, hold on, let me just step through the scale function and then figure out why are we here? What? F11. What just happened? Alright, I'm gonna have to take another break. let's continue with this. At least draw something resembling a correct histogram for the sums. Okay. Let's see. What do we got? Oh yeah, what are we actually running? No, I wanted to step through that, I think. Why are we here? OG range. That value 0, 1 is that, which I think makes some sense. Value minus min divided by range, yes. Min is 0, yeah, range is that, value is this, yeah, that makes sense. New range is that, so new value float is that, and int, you just kind of floor it. Yeah, that's, why are we here again? What? Okay, the debug info is definitely busted. Indeed, which is, yeah, I mean, debug info being busted in every language other than C is like a pattern at this point. And even in C, hit and miss. Can we flip the rectangles? So these are the rectangles that go top down. So what happens when the height is negative? Does it go up, or like, are we allowed negative height rectangles? Or do they just disappear? Well, in this case they might disappear because of bounds y plus bounds height. So that will go to the bottom. No, they just disappear. Negative height rectangle disappear. Okay, well, I mean, so height is that, and x is, I mean, y is that, so this is the upside down histogram, right? Yes, this is the upside down histogram. So at this point we can say that instead of going from here to here, let's just move it down. Hist rect. Okay. Mu rect flipped hist rect is hist rect. Well, I mean, it's so the x is going to be hist rect x, the y is going to be hist rect y plus the offset, and the offset is hist rect height minus the total range, right? Bounds height. So it's the difference between bounds height and hist rect height. So bounds height minus hist rect height. So that's the y. Then actually, is that the only thing we need to change? Just the y? Yeah. So we can just do that then. Well, wait, what? Oh wait, height, no, y. Yeah, there we go. So now the histogram is the right way around. Presumably, I mean, assuming these are the correct values. Okay, let's make the color be a little less bold. A little less bold, like some kind of gray, I don't know. Yeah, that'll do. Int array temp sums is well, 10 is probably a bit much, so let's say 4. Let's do 1, 100, 1000, 10,000. Okay, well, I mean, that does seem to be making sense to me. And let's make the last one the result top 3 sum, so that's the top sum. No, max sums. Yeah, that's yeah, that seems to be what we want. Yeah. And if we just do the second highest, yeah, they're a little different. Yeah, okay, so this seems to be working. It seems to be working fine. Result sums 0, result elf count. Alright, well, there we go, there's our histogram. At least that's the beginnings of it. It'd be nice to have a scale. And since each histogram is really composed of multiple numbers that are added together, we can show that and create multiple sort of rectangles here that are stacked on top of each other for each of these, for each of the histogram elements. And we can also sort them, because we kind of want to know what the maximum is, right? So we can sort them, and if we sort them and we have a scale, then we'll immediately kind of be able to read, or we should be able to read that number from the scale. Well, not exactly, but approximately we should be able to see that that histogram is sort of right at the top. Alright. But that's for later. Let's close that. Focus. Well, yeah, that's just input. It's yeah, this is fine. And those are the only changes. So start on histogram. Alright, that's it for today. See you later.